Hi, I'm Peter ffoulkes with OrionX, and on behalf of insideHPC, we're having a discussion with two Intel executives about machine learning today. So I'll hand over to Joe Spisak to introduce himself and his role, and then to Pradeep Dubey for the same thing.
Hi, I'm Joe Spisak. I'm part of the visual cloud computing team. I lead strategy and business development for machine learning for Intel, focused on visual workloads, including natural language processing and image recognition.
Great. Pradeep?
I'm Pradeep Dubey, Intel Fellow, also Director of PAL Computing Lab. We look at emerging applications on our upcoming architectures, both high-performance computing, machine learning, anything that's compute-intensive, data-intensive.
Okay, great. Well, we're here today to talk about machine learning, which many people are looking at as the next big thing. It's exciting, yet it's not well understood. So if we look at that opportunity, it shouldn't be a surprise, but why are you doing this now? And what's the reason for all the attention on machine learning? So let's start off with Joe.
Yeah, I mean, I think we're to the point now where big data is everywhere, but it's not just big data. It's the ability to analyze and annotate the immense amount of data we have. We can't humanly do that, so I think we're ready to turn it over to the machines and let them take a go at it and actually understand so they can mine it and generate some value from it.
And is that the same sort of philosophy you have? Do you want to expand on that, Pradeep?
Yeah, it's basically three things. There is the why now question. One, as Joe said, large amount of data is now available. Large amount of compute is available to actually go make sense out of it. And also we're living in a connected world, so you can actually connect and iterate through these machine models real time. So that connectivity, pervasive connectivity, massive compute, massive data, the convergence of all these three is magic for machine learning.
Okay, great. So we all understand the sort of concept of artificial intelligence and things like that, but there's a lot of confusion in the marketplace about the terms machine learning, deep learning, things of that nature. So are these things synonymous? Is it just the same words for different things? Or is there actually a difference between machine learning, where presumably the machines are learning, or is it something else where there's more insight and deep learning means something else?
Yeah, so these terms are used interchangeably today, machine learning, AI, deep learning, but they're really different terms technically. So let's just clarify machine learning, deep learning. Deep learning is a subset of machine learning. Machine learning in general refers to a class of algorithms where performance improves over time as more and more data gets crunched. Deep learning is a subset where you're dealing with deep networks between the input and output layer, which is not necessarily the case with the rest of machine learning.
Okay, so that's good and that's helpful. But from a functional point of view, when we're looking at machine learning, what do we mean by training? What's scoring? What are the sort of terms that people need to understand? What are the attributes of those, Joe?
Yeah, I think so. If you look at training, that's really iterating over the data that you have, the immense amount of data you have, and creating a model. And really the goal there is to train as quickly as possible and enable iterative research. When it comes to scoring or classification or inferencing, depending on which term you use, really is the ability to do it efficiently and be able to classify or score new information that's out there in the wild, whether it's a new image or a new piece of voice or other types of data.
Okay, so can you put some sort of flesh on that by giving some concrete examples of use cases in the real world? You know, either one of both of you. Who wants to go first?
So there are many examples, right? Just take an example of, for example, images, right? So you train the machine by feeding labeled images of, you have found, humans have labeled it's a cat or a dog or a flower, and machine gets trained. Now once it's trained like that, then its ability to actually go and classify a flower as a flower, the one that it hasn't seen before, goes up. And hopefully it will very accurately, sometimes even surpassing human accuracy, can actually accurately classify a flower as a flower, a dog as a dog.
Mm-hmm.
Yeah.
Joe,
Yeah, I think it's, I mean, certainly image and video and speech, are the sexy applications and topics that people are pursuing today. I think there are a lot of unsexy ones like fraud detection, sentiment analysis, like things like Twitter use to understand, where things are trending and kind of where the voice of the market is going. So I think it's pretty pervasive in many applications today. Search now, as Google has recently has moved their entire RankBrain search engine over to basically machine learning algorithm.
Okay. Now, people have been talking about artificial intelligence for decades, and yet it hasn't really come to fruition. And yet, we're now moving into a new era with all sorts of changes in computing. I mean, if we thought the last 5 years was disruptive, I don't think we've seen anything yet. And there are new technologies coming on stream. You know, you guys clearly have got great processor technology, but you need other things like fast memory, other things like that. And you're working in partnership, I think, with Micron, and you've just announced 3D XPoint. So how do technologies like that play into the whole area of machine learning?
Yeah, so it's the biggest thing in machine learning is really training part, right? And training such that you don't need human experts to tell you what the right features are. Machines on their own can figure out the right features by crawling and mining massive amounts of data. What that means is that you need to be able to hold large models, large data, and that is where memory comes in, right? If we can actually hold a large amount of large models and train large models with large data, after we are done training, that will probably be a very compact model. But to begin with, it's a very large training data set, training model, right? So we start with very large, and our ability to hold in a memory nearby, our ability to communicate with computing cores through low latency, high bandwidth, all those things are immensely critical when it comes to training large models.
So this is actually a very sort of broad relevance to many parts of the industry. So Joe, what particular segments do you think are going to be the key ones? What kinds of applications? Where are we going to start first? Where are we going to go into? So how is this going to grow?
Yeah, I mean, it's starting with the cloud, and it's starting with cloud applications. You know, our customers like Facebook, Google, Baidu have deployed applications for the more visual understanding-centric workloads. But very quickly, it's moving into medical research, it's moving into financial services, and many others. You know, we see machine learning kind of weaving its way into kind of all of the applications out there in research as well as in the industry.
So as a follow-on to that, I mean, this sounds like it's a huge opportunity. It sounds like we're going to be doing breakthrough and new things that are going to have significant changes. How big is this market? What's addressable? And, you know, is it something that Intel can address all of it, or are you going to do it with partners? How's this going to work?
Yeah, it's a challenging question. It's very hard to quantify the opportunity. If you look at some of the recent market research, like Tractica in Q4 15, they claim that it's over $100 billion of addressable market for all the applications taken into account. I think we believe it's a huge opportunity for us, and we're investing for the future to address it.
So when you say something like $100 billion, is that tomorrow? Is it 2020? Is it 2025? How's that going to go?
It's in the 2024 range is where they pegged it.
So we're really looking at the excitement is not just tomorrow, but it's the next 5 to 10 years, which is pretty significant.
That's right.
Yeah, I mean, I'm a research guy, so I can't give you numbers, but let's look at it very differently, right? We are talking about a whole class of problems where computing has not done a thing, right? So it's a very large market where computing today plays no role. I mean, what are we talking about? We're talking about farming, transportation, education, health, teaching, all of this stuff. These are all what I call human-led services. That's why they call service sector. What we are talking about is machine intelligence leading and humans at the back seat, literally the self-driving car analogy. So humans are taking the back seat and machines are taking the front seat for these services. That's what is transformational. So computing has not, the growth opportunity here can't even be put down in numbers.
But we're not really talking about, you know, Skynet and Xylon 6 here. We're not making humans irrelevant. What we're doing is freeing them up to get better data and do things. So you guys are clearly very passionate about this. So just to sum up, because clearly you're both heavily invested in this, I can tell, what is it that personally excites you the most? Let's go back to you, Pradeep, first.
That's the part that excites me most. There has been this natural balance between machines and humans, that machines are not challenged when it comes to doing number crunching, and humans are not challenged when it comes to doing complex decision making. That balance is what's about to be disrupted, and that's very, very exciting.
Excellent. And Joe?
Yeah, I think it's a new class of workloads and applications. When it comes to even cancer research, I mean, we're using machine learning, or there's researchers out there that are using it to really kind of take it to the next level and learn more and be able to dig into these really hard problems that haven't been even attempted to be solved before. So I'm excited about the applications.
And that sounds great, and maybe it sounds like we're going to be doing regular coverage with insideHPC over how this develops, when you bring the first things to market, when you move forwards, and then if we've got a 10-year window, this is going to be fun, I think.
I think so.
Well, thank you very much. And on behalf of Inside HPC, I'm also very excited about machine learning, deep learning, and how this is going to roll out. I do think it's one of the big things that we're going to have. And it's also nice because it really brings the back end of HPC right into humans' everyday life. Even if they don't know what's happening, they're using the services. So thank you.